Hi, welcome to the exam collection. We've got our normal 6 questions that are all crossover that should help get you ready for those all-important exams. They are all calculator questions now, so you can grab that useful tool and use it throughout. If you're new, then basically I just chucked 6 questions at you. It's a snappy piece of revision that should be done really regularly in order to get you ready. So hit pause and press play when you want to see the solution. Okay. So Colin, Dave and Emma share some money. Colin gets 3/10. Emma and Dave share the rest. And this is the first kind of hurdle that we've got to get our heads around, is the fact that we don't know how much money. Now, we could start modeling this by pretending a certain value existing, and that's fine, that works. But actually just try and think through what they're telling us. If Colin gets 3/10 of the money, then Emma and Dave get what's left. They get 7/10 of the money. We're told about the ratio that they get the money in. So this is Emma and this is Dave, and it's all about Dave's share. So that's what I'm focusing in on. So if they share in the ratio of 3:2 as a fraction, Dave will get 2/5. Okay, Emma would have got 3/5. And just doing that to remind you that actually ratios are just numerators of fractions, and you add those ratios to get the denominators. So what do I know now? I know that 7/10 is the rest of the money. Dave gets 2/5 of the rest of the money. So Dave gets 2/5 of 7/10. Of means times in maths. So we just do this by just doing it 14/50. They have not asked for us to simplify, so you don't need to worry about anything like that. That is the answer. And of course, if you put that into the calculator would have simplified it for you anyway, which would have been 7/25. Okay, next question. Pause and press play when you're ready. Okay, so we're being asked to find the mean from a table. Now, if you are not taught by me, you might not have seen this method before. That doesn't matter. It's not about the method. It's just about making sure that you have the right answer and you've got all your workings out to show. Okay, so you get all your method marks. So mean should trigger MAD method. MAD reminds me of the order I do everything in. I multiply, I add, I subtract. So if I'm multiplying, what do? I multiply across that table. So I've got 4 times 0 is 0, 5, 20, 21, 12, and 5. So that's my multiplying done. I then have to add. Well, it makes sense to add those numbers as I've just got them, so 63, but I also add the total frequency, which is 30 in this question, because let's not forget when we're finding the mean, we're adding them all up and dividing by how many are there. This is the how many are there. Some people divide by the number of rows. Very easy to make that mistake. So 63 divided by 30, divide with my last step. This gives me 2.1, but it does say how many customers could be sitting at the table. And you can't, so we want to round that to a whole person. All right, next question. Hit pause, press play when you're ready. Okay, so exchange rates can be done using our boxes and labels. Again, this may be an unfamiliar method. However, as long as you've got what you've done backing up your steps, it's all good. It's all good. So my first fact in this question is about the exchange rate in 2010, where £1 is 67.1. And we're told that in 2010, he changed £600. So 600 goes into that column. My trap number is 1, so that's what I divide by. Not going to make any difference in this particular question. And 67.1. So I pop that into my calculator and I get that. Now I'm just going to repeat the whole process for my 2012, which is 1 and 82.5. But this time we want to know how many pounds he'd have to change in order to get the same number of rupees. So the same number would be that number. So that's going in. My trap number this time is 82.5 times through by 1 is not really going to make any difference here. Just show it because it's in my box. And I've got £488. So if you got that right, well done. Next question. We've got an angles question. Hit pause, press play when you're ready. Okay, so one of the big things here when we're doing an angles question is to not forget this, giving reasons for your answers. It's really, really common to get so involved in the diagram and finding those missing angles that we start to forget that we need to write those reasons, and they are half our marks. So it's really, really important. So the first thing that you do with a diagram like this is just digest it. Just take in everything that you can see, all the information they give you, and actually what they don't give you, because one of the first things that I'm going to do is use a triangle, but there's no mention of triangles in the blurb, is there? So it's really taking your time to think about what you can see. So I can see here that I have a triangle which has 2 angles in it, making it really easy for me to find the third. So that's where I'm starting the problem. One of the things with angles is you can pretty much start where you like. It's quite common for people to move around a diagram differently. And obviously that's fine. So we're going to do 180, take away the 54 and the 90 degrees, which will give us 36 degrees. And don't forget the reason. The reason is angles in triangle are equal to 180 degrees. The other thing that I'd really encourage is go in and mark that angle on, because actually seeing it in the diagram can sometimes really help you with your next move. So my next move was this. I've got the parallel lines. They've made a big point of that. And generally, if they're there, they're going to be useful. So those are my 2 parallel lines. When I join them up, which requires me to highlight that line, I can see the Z. I can see that that angle there must equal this angle here because they're alternate. So I can now say that angle BAC is equal to 76 degrees because they're alternate. And I can really see now everything coming together here in the middle. The X has to be this 76, take away this 36, and it will leave me that bit there. So to finish it off, 76 take 36 equals 40. X is equal to 40 degrees. Okay. These are simultaneous equations. Hit pause, press play when you're ready. Okay, the first thing to do with simultaneous equations is to get the first terms the same. And actually, they already are. So there's no work required. I can go straight into the taking away. Now, I always show my takeaways, take away, take away, take away, because it's the very fact that simultaneous can go into negative numbers that can cause a lot of issues. So it's easier to just see them on the page really clearly. So X take X, the X's have gone. That's the point of the method, so that's all good. The next one is 2y minus y. Those 2 negatives are going to make a positive, so I'm going to be adding, giving me 3y. But then 3 minus 6 is minus 3. So divide through by the 3, and y is equal to -1. Now you choose the simplest. I quite like the look of the top one, so I'm going to use that one. X plus 2y even equals 3. 2y I can work out because I know what y is. Y is -1. 2 times -1 is equal to -2. So what I've got now is x minus 2 equaling 3. Then get x on its own. X must equal 5. So you'd write on the dotted line, y equals -1, x equals 5. Okay. Last question. I want you to hit pause, have a good go at that, and then press play when you're ready. Okay, so there's quite a lot going on in the diagram, but when you break it down, hopefully it's not too bad. The shaded region is in this quarter. So if I find a quarter of the big circle, I'm on my way. Really, what I'm looking to do here is I want to find the quarter of the big circle, and I want to take away, I'll highlight that as well, I want to take away half of the small circle. Half of the small, squeeze it in there. That's going to equal, obviously, that sort of shaded region that we're trying to find. So let's work on this bit first. A quarter of the big circle means to do a quarter of, or a quarter, or divide by 4 at the end, whatever works for you. Pi r squared, which is pi times, the radius will be 10. When you do this, you will get 25 pi. If you've already changed it at this stage to a decimal, it's going to look like that. I want a half this time of pi. R is 5 squared. That's going to give me 12.5 pi, or 39.2699, and on it goes. Now, if I do that takeaway, it will give me 39.269, on it goes. I don't know if you spotted, but that is just half of that, okay? And to one decimal place, we've got 39.3, and that will obviously be centimeters squared. Okay, so hopefully that was useful. I'm going to be posting these really, really regularly in the run up to the exams. I'm also making paper 3. The difference in time between paper 2 and paper 3 is very short. So you don't want to leave your paper 3 revision until the last minute. So really, I would be advising you to do both over the course of the, few weeks, 2.5 weeks that you've got. Okay. Thank you for joining us on this tutorial. Hopefully it has been useful.